Hello, my name is Sharita Powell. This presentation will provide an overview of brain implants. In this presentation, characteristics, capabilities, purpose, science and mechanisms, and social and ethical concerns on brain implants will be discussed as well. This will provide insight into how our motor systems work in real life. Let's begin. Brain implant characteristics. What are some of the characteristics of brain implants? According to research, neural tech involves using BCI and neural interfaces, brain implant technologies, and EEG control of robotics with the anticipated endeavors to do much more. Some essential characteristics of brain implants are that is a small silicone device inserted in the brain, monitored and records neural activities, and it sends and receives electrical impulses and cues, signaling for communication. It essentially works like neurotransmitters. This advanced technology has stunning capabilities. Some of the current research capabilities of BCI are detecting signals in paralyzed muscles, reading neural signaling, or reading an individual's mind and controlling electrical impulses within the brain. There are many ethical concerns in using BCI. For research, and many studies are underdeveloped yet conducted on human subjects with paralysis. For the sake of time, the focus will be on brain implants. For individuals that have paralysis, more specifically, tetraplegia. Excuse me, I butcher those names there. A recent study was conducted on an individual with tetraplegia using an intracortical brain-computer interface. It revealed how people with paralysis could control assisted devices with simply the intent to move. Neural activity was detected from precentral frontal gyrus, also known as PFG or primary motor cortex, which is responsible for executing voluntary movements, and the left middle frontal gyrus, also MFG, responsible for literacy information. Activity in selecting and generating movements, while MFG revealed preceding actions during the sensor motor process. Again, both actions of the MFG and PCG were recorded when instructed by auditory cues only. This process reveals the power of auditory cues from the environment and the complexity involved in neural transmission to move, but happens with less than a second. More importantly, it provides individuals who have paralysis a way of communicating. Movement to limbs, improving functionality, quality of life. It is just something that can really help them out to communicate, period, with the world around them. There are several benefits to advanced technology of brain implants. It can provide independence and functionality for individuals with paralysis of any form by giving them ability to communicate and mobility to use limbs that were once paralyzed. Furthermore, brain implants provide information on how neural activity works for future references. Now, there are some ethical and social concerns about brain implants, of course. Some of the ethical and social concerns are malfunctions, allergic side effects, privacy, access to private information, targeted marketing scams, and the enhanced ability to receive information quickly may compromise integrity, honesty, and eventually the ability to retain important information. I hope you enjoyed this presentation and found better insight about brain implants and their characteristics, purpose, capabilities, the science involved, and ethical concerns.